the opportunity to do so virtually. We believe in the power of science to help lead us down the right path, solve problems, inspire critical thinking, and make the world a better place. We believe this natural world around us is an irreplaceable resource to be respected, loved, understood, and cared for. We're committed to diversity and equity and inclusion throughout our organization's culture, policies, curriculum, programs, and partnerships, and believe that everyone should have the opportunity to enjoy Mount St. Helens. We always have, and we always will. No matter where you're joining in from, recognize and learn about the Indigenous land on which you live. Mount St. Helens Institute operates on the traditional cultural property of the Cowlitz Indian tribe and the confederated bands and tribes of the Yakima Nation. We're proud to have the Cowlitz Indian tribe as a partner, where they fill multiple seats on our board of directors, and together we offer joint programming to Cowlitz youth and the general public. And if you're out there and you're enjoying Views and Brews, or you enjoy the work that we do, consider making a donation at mshinstitute.org/give to ensure that we can continue providing this great event and ones like it. There's also a link in our lives that we'll put in our live stream chat. Thank you. We so appreciate your support. And throughout this event, we'll be collecting questions via our Facebook chat on the live stream. Feel free to send a message to the speaker and I'll collect them in order to answer them in a Q&A at the end. So to all of you joining us out there tonight, whatever your brew is, cheers. Tonight we present the ecological recovery story of Mount St. Helens with our speaker, Eric Wagner. Eric's a Seattle-based writer, and he's also a biologist with a Ph.D. in biology from the University of Washington, where he regularly writes about animals and the environment. And his newest book, After the Blast, was released last month. So without further ado, I welcome Eric Wagner. Give us just a moment here while we bring Eric in. All right.
Hello. Thank you for joining me remotely. I'm sorry that we can't all be together now, but perhaps this is the next best thing. So today I want to talk to you a little bit about my new book, After the Blast, the Ecological Recovery of Mount St. Helens.
Oh, looks like we just have a quick technical error. Please hang tight.
Hello. Thank you for joining me remotely.
Well, cheers to technology. All right, let's try this again. Here we go.
Hello. Thank you for joining me remotely. I'm sorry that we can't all be together now, but perhaps this is the next best thing. So today I want to talk to you a little bit about my new book, After the Blast, the Ecological Recovery of Mount St. Helens. And so this is Mount St. Helens as it looks today, more or less. And it's within the Pacific Northwest. It's a pretty iconic landscape, the mountain, the crater, the blast area. And the eruption itself is a real sort of regional marker. Everybody who was alive then sort of remembers where they were when they heard about it and what happened. And so because of that, it's very familiar. And this gives it a sense of being a very known story. And so when I was working on the book, I would tell people that I was working on it because that's kind of what you do. And they would say, oh, you're writing about Mount St. Helens. What are you going to say that's new? And for me, this was a little bit of a frustrating question because at the time I was reading pretty much all that I could about Mount St. Helens. And to me, almost all of it was new. And I was struggling to wrap my head around it. And so what I want to talk to you a little bit about today or show you is some of the things that are new about this very familiar story and to show how it's developed as the 40th anniversary of the 1980 eruption is upon us. But first, what I want to do is situate the mountain for you. And so Mount St. Helens sits in what's called the Ring of Fire, which is a 25,000-mile arc of volcanoes that runs from the southern tip of South America up through Central America, North America, across the Aleutians, over to Russia and down Japan, Malaysia, Indonesia, the Philippines, and then over to New Zealand. And so among these, Mount St. Helens is part of the Cascade Range in North America, which runs from southern Canada, which apparently does not exist to the U.S. Geological Survey, down to northern California and Lassen Peak. And the Cascade Range is made up of 18 volcanoes, of which Mount St. Helens is the youngest. The vent over which it sits is only about 40,000 years old, and the prominence, or the part that we think of as the mountain, is only 4,000 years old. And so in geological terms, Mount St. Helens is just a baby. But it's a really squawky baby. Of the Cascades, it's easily the most active, and it erupts about every 140 years on average. Not that you necessarily would have known this to look at the mountain in 1979, which is what this picture shows. So you can see this is Mount St. Helens in all of its glory, as seen from Spirit Lake. And Mount St. Helens then, it was the most beautiful of the Cascades. It was sort of considered to be its peak, the most symmetrical, and it was called the Fuji of North America. And this beauty and this symmetry was due to Mount St. Helens' relative youth. So, because it was so young, glaciers hadn't really had time to carve up its summit yet. And so it looked all, nice and pristine. But human and geological time horizons would sort of meet in the spring of 1980 in mid-March, when a series of small earthquakes signaled to geologists that magma was on the move underneath the prominence. And so it was sort of rising up into the mountain. And so what happened was a magma chamber formed under the north flank and began to fill. And as it filled, it began to bulge. And it was expanding by as much as 5 feet per day. And during this time, Mount St. Helens is getting shaken with small earthquakes, and magma's coming up and it's starting to bulge. And then through March and April, there were a series of steam and ash eruptions. A crater opened up on the summit and began to expand until it was several hundred feet in diameter. There were cracks in the summit too. And then this led to the morning of May 18th, 1980. And so this is a photo taken by a person named Gary Rosenquist from Bear Meadow, which is about 11 miles east of Mount St. Helens. And he took this photo at 8:27 a.m. And at 8:32 a.m., a little bit after that, an earthquake, a 5.1 earthquake on the Richter scale, shook the mountain, and its entire north flank and summit collapsed in what at the time was the largest landslide recorded in human history. So all of this rock and rubble just sort of flowed off the mountain. And then once the north flank and the summit were gone, they had been what had kept the magma chamber. The magma chamber was filled with gas and superheated water. And so absent the pressure of the north flank and the summit, all of it flashed to steam and burst out in these clouds, or what is called the lateral blast. And so Rosenquist captured that. He captured the development of the lateral blast clouds, which just exploded out. And what I'm going to show you next is a series of photos taken from the west side of the mountain that shows more of the lateral blast. So you can see it just explodes. I mean, this tremendous, you see, however many times the force of however many nuclear bombs, something in the range of the hundreds. And these clouds fly out over the land at about 600 miles an hour. And so once the north flank has collapsed and the lateral blast has sort of carried itself away, a plume of ash began to rise from the vent, ash and pumice. And it eventually climbed up 15 miles in the sky. And geologists estimated that it was made up of 500 million tons of ash, just billowing out. And prevailing winds began to blow it east. And then a few hours later, what were called the pyroclastic flows began. And this was boiling hot pumice actually way more than boiling hot. It was something like 1,500 degrees, boiling out of the vent and spilling over the sides to sort of flow down the front of the mountain at 80 to 100 miles an hour. It was really something, or so I've heard. And so when it was over, the cataclysmic eruption, the major eruption, lasted 9 hours. And when it was done, this is what was left. A mountain that had no longer had the perfect peak, but in its place was this gaping crater. It was a mile across and more than 2,000 feet deep, all over this sort of apocalyptic looking landscape that was just black and gray and steaming. And so this is what it looked like from sort of a landscape perspective. And this is a composite image of NASA satellites, or taken from NASA satellites. And so one of the things about the eruption was that instead of going up, which is what most people expected because that was what folks thought that volcanoes did, Mount St. Helens had erupted largely out. You can see that the most of the effects are to the north of the mountain. And I mean, there was some to the south. There were some pretty significant mud flows. But as a sort of landscape feature, it was the north that caught the brunt of the eruption's power. And so as a consequence, this left behind a number of distinct sort of disturbance zones. And so you can see these here. This is a map that shows the different disturbance zones. And so the blast area as a whole covers over 200 square miles. And you can see that the largest sort of the disturbance that covers the most area is called the blowdown zone. And so this was the lateral blast clouds, which had flown over the land and flattened all of the trees that had been in what had been a forest, just sort of knocked flat in seconds. And at the end of the edge, this sort of orange fringe around the lateral blast and the blowdown zone is what's called the scorch zone. And this was where the blast clouds sort of lost their energy. The energy, it was dissipating, so they didn't have the power anymore to knock over trees, but they were still hot enough to kill them. And so this left this sort of this fringe of standing dead trees up to about 17 miles from the mountain. And the yellow that you can see is the debris avalanche deposits. And these were confined largely to the valley of the North Fork of the Toutle River. And there are several hundred feet deep of rock and glacial ice and mud and other sediments, organic material. And then the bit in front of the mountain, that sort of brown patch, is the pumice plain. And this is made up of all the pumice from the pyroclastic flows, several hundred feet of that. And so this, when ecologists had to wait a couple of weeks before they were allowed to get into the blast area because the eruption had killed 57 people, and search and rescue was very busy trying to hunt for missing people and also to rescue survivors. And so ecologists didn't get in until for a couple of weeks. And when they did, they were flying in by helicopter, and sort of this is the scene that they saw. This is an image from the blowdown zone. You can see all these trees that have just been knocked flat. And it's just entirely gray. It was a landscape of just overwhelming grayness. And the general sort of consensus among them was that nothing could possibly have survived. There was no hope of finding anything alive in this area. But for them, they thought, wow, what an opportunity. Here's a chance to watch life sort of come back after it's been completely destroyed. And in this also an opportunity to test some of ecology's oldest and most august theories of succession. And so they were prepared to just sort of watch stuff creep back over what they assume would be years, if not decades. And so they are flying over all of this in a helicopter, and they land at a place called Orion Lake, about 8 miles northeast of the mountain. And an ecologist named Jerry Franklin opens the door to the helicopter and hops out. And what should he see at his feet but this little green plant shoot poking out of the ash? And he recognized it as a fireweed. So fireweed is a very common species. It's found all over the world. It's sort of popular as a garden plant sometimes. Some people like it, some people consider it a pest. And one of the reasons for that is that it grows really, really well. It's a pioneer species, sort of a classic pioneer species in that it prefers disturbed habitats. And so Mount St. Helens was perfect for fireweed, and fireweed was perfect for Mount St. Helens in the immediate aftermath of the eruption. And so this shows kind of what the process of fireweed looks like. This is a patch of land that somebody just took a picture of in the beginning of the summer, and fireweed, and then they return to it, and here's the fireweed growing and growing, and then it grows very, very fast, and then it sprouts at the end of the summer. And when it does that, it produces thousands and thousands of seeds, light, fluffy seeds that the wind picks up and can blow for miles. And so it's a very effective disperser. And so Jerry Franklin, he's looking at this, and he's looking at this fireweed, and he knows that it is not from a seed because it's May, and so it's too early for that. And so it could only have come from some remnant bit of root, because fireweed is hardy enough that it can resprout from just a little piece of root if a little bit of root is left over. And so what he surmised was that this little piece of root had somehow, persisted, getting rolled over by the lateral blast clouds and then sprouted. And when he looked around some more, he realized it was not just fireweed, but there were other species as well. This is a picture of some huckleberries that are growing out of the root wad of an overturned tree. And here are some pearly everlastings that were growing out of cracks in the ash. And so this was not what ecologists expected to find at all. They had expected to wait and just watch life creep back. But instead, they realized that the response to the eruption, it would be rapid, it would be diverse, and it would be full of surprises. And so above all, what they thought was, we really need to study this. And so in part because of their efforts, the Mount St. Helens National Volcanic Monument was created in 1982. And so the monument is about 110,000 acres, mostly north of the mountain, that is sort of set aside as a place for geologic forces and ecological succession to continue substantially unimpeded. And so the research that took place in the monument would show that there were sort of two main influencers when it came to the biological response to the eruption. And these were survivors and colonizers. And so survivors were the sort of biological legacies from the pre-eruption community. So the fireweed, pearly everlasting, other plants, but also small mammals and amphibians, things that had survived in burrows or underground, in the mud, or were somehow otherwise shielded from the worst of the eruption's effects. And then again, opposed to these sort of would be the colonizers, which would be those species that were coming in from outside the blast area. And so there would be things growing from within the blast area and things arriving from outside the blast area. And so within this sort of framework of survivors and colonizers, there were two main species that came to be seen as kind of exemplifying each. And so this, for the classic survivor, was the northern pocket gopher, which had survived in the tunnels that it dug, sometimes pretty deep underground, and so it was spared the eruption's worst effects. And the classic colonizer was the prairie lupin, which was a flower that biologists found growing on the pumice plain a couple of years after or actually in 1981, or growing on the pumice plain after the eruption, having arrived, they knew not how, and totally sort of flouting its conventional natural history. Nobody had expected that a prairie lupin would be the first plant to respond. And so these are the sort of the classic ecological survivors. You will be able to read about them in the book, and After the Blast, I talk about them both. But one of the things that was kind of funny about writing this book was when I was talking to one of the main biologists, and he would say, "Oh, what are you going to talk about?" And I said, "Oh, pocket gophers and prairie lupin." And he was like, "Please talk about something else. Everybody talks about pocket gophers and prairie lupins." So for the rest of the talk, although as I mentioned, you can read about pocket gophers and prairie lupins, what I want to talk about is a couple of species that for me embody the mountain's sort of past and present and perhaps future circumstances, and show some of the complications that arise when, as the research has sort of extended further in time, they show the complications of how people think about Mount St. Helens and the sort of relationship that we have with it. And so the colonizer that I want to talk about is the rainbow trout, and the survivor is the elk. And so I think of these as both as sort of more modern mascots, if you will, that illustrate nicely some of the tensions inherent to the monument's aims and purpose. And so I want to start with the rainbow trout. And so the rainbow trout is a salmonid, which means it's in the same family as Pacific salmon. It's a very popular game fish. It's been introduced all over the world. There are a number of subspecies. It's just kind of everywhere. And so the story of the rainbow trout at Mount St. Helens is sort of the story of Spirit Lake. And so this is what Spirit Lake looked like before the eruption, if you remember this picture. And at that time, it was a pretty typical Pacific Northwestern mountain lake, which is to say it was deep, it was clear, it didn't have a lot of nutrients, so it's what's called oligotrophic. And as you can see in this picture, it was also very popular as a popular recreation site. So on its shore, there are a lot of cabins and lodges and camps, and people like to come and sail on it and swim and fish. And so all of that changed, as you might imagine, with the eruption. And so this is what Spirit Lake looked like in 1980. So what happened to it is with the debris avalanche, the landslide, it sort of came down in 3 blocks. And so the first block slammed into Spirit Lake, and it hit it so hard that there's some speculation that the whole basin may have emptied as all this water sort of sloshes up the hillside. And when that happened, so the lateral blast clouds had flown over and knocked down all the trees. And then suddenly all the water comes up and grabs all the trees and all the soil and all these dead animals and everything else and drags it all back into the lake basin. And so this is what was left. This lake, the lake bottom was 200 feet higher, just filled with debris. Its surface area had increased from 1,300 acres to 2,200 acres. And the top of it, you can see what looks like this kind of skim part those are actually logs, thousands and thousands of logs of trees that had been on the hillside before and had been dragged back into the lake. And so this is what researchers faced when they arrived at Spirit Lake in the summer of 1980. This is an image from the southern shore showing somebody looking out at it. It was this black sort of stinky broth, where on land, people had expected nothing to survive and then found that there had been survivors in the lake. They knew there was no chance that anything had survived. Such was the violence of the eruption to the lake. So it's just black and it's stinky. What they did find eventually were that these 2 new species of Legionella, which is the bacteria that causes Legionnaire's disease. And so researchers working at Spirit Lake in that first summer had come down with what was called red zone fever, and they later determined that it was caused by these Legionella. And they found 2 new species in Spirit Lake, and they named them Legionella St. Helensi and Legionella spiritensis to commemorate their origins. But as they studied, what they found was that the dynamics at Spirit Lake were sort of completely the opposite of those on land. So where the land had survivors that were sort of slowly repopulating, the lake was empty, but soon, or empty of life. But soon, what with all the organic material, bacteria just flourished. And so they made the lake bubble sometimes with their activity as they consumed all of the organic matter that had been dumped in the lake after the eruption. But at the same time, there was a sort of an influx of rain and snow melt and inflow from area streams, and these steadily cleared the water. So what this image shows is 2 sort of water samples, one from August 1980 on the left, and another from May 1981 on the right. And you can see that by just a year later, the water has become a lot clearer. And so in 1982, researchers started to find phytoplankton and zooplankton, and the lake itself was totally clear, or was basically clear by 1983. And so this was sort of called the recovery of Spirit Lake. But it was a new lake. It should be emphasized. It wasn't like Spirit Lake went back to what it had been before. Instead, this is it from 2004, there were a lot more nutrients. So Spirit Lake had gone from being oligotrophic to what would be called eutrophic. And so with those nutrients, there were more plants, there were more organisms like aquatic invertebrates or bugs. And so as the lake was clearing, state biologists wanted to know about fish. So several lakes around Mount St. Helens had been stocked before the eruption, usually with like brook trout or cutthroat trout. But one of the most popular game fish to stock a lake with is Spirit Lake, is rainbow trout. And Spirit Lake had certainly gotten its share. Stocking efforts had begun in the early 20th century. And so by 1979, Spirit Lake, state biologists were planting about 40,000 rainbow fry or fingerling in the lake every year. And so what this image shows is a biologist doing a survey of another lake in the Mount Margaret backcountry after the eruption. And so what they would do is they would go out and they'd throw a gill net out and they would bait it with chicken, and then they would come back and see if there are any fish. And so after the eruption at these lakes in the backcountry, they found fish that had survived. A lot of brook trout had done, the way they'd survived is that the lakes had been frozen over in May, and so they were, covered with ice. And so when the lateral blast cloud swept over, and the trees all fell down, maybe the fish in the water felt a kind of thud overhead, or the ground kind of shook, but they were able, they weren't killed. And so they weren't doing very well, their growth was pretty stunted, but they were alive. And so there were these surveys throughout 1981 and 1982 found living fish in about 2/3 of the lakes around Mount St. Helens, but nobody had really bothered with Spirit Lake because they knew that there was no way that there had been fish. But they still did occasional surveys. And finally, in one year in 1993, surveyors found a single rainbow trout. It was a male, and they were just so surprised and thrilled that they named it Harry, after Harry Truman, who was the cantankerous owner of the Spirit Lake Lodge, or the Mount St. Helens Lodge, that had been on the shore of Spirit Lake and had famously refused to leave his home and then been killed in the eruption. And then the next year they came back and they found another trout, It was a female this time, and so they named it Harriet. And so they kept returning and they kept surveying, and they would catch a few rainbows each year, but, not a lot. And then finally in 2002 was what they had the big year. So this image shows two state biologists, Bob Lucas and John Weinheimer, and they were out fishing on the lake, and Lucas caught a giant trout. And that was the year, as he said, that they realized that Spirit Lake had finally turned a corner. And so they went out and they surveyed and they caught all these enormous trout. And that was the Spirit Lake trout. They were something else. They were big, they were bitey. They had the entire lake essentially at their disposal. And so there were some of the largest trout found anywhere in the world. They were over 2 feet long. They weighed more than 4 pounds. But where were the trout, where they were from was a bit of a mystery. Nobody really knew. There was there's this sort of series, a lot of apocrypha about how they got there. Did somebody cart them up? Did somebody from the Army Corps of Engineers put them there at some point in the early 80s? There's a story going around that, Bob Lucas was home one night and somebody called and said, "I'm the guy who put the fish in," and then just hung up. But anyway, so somehow, but now there were trout in the lake, and they were gorging themselves on something. And so, the biologists who were working at Mount St. Helens, they knew that the lake, or that the trout may not have gotten there naturally, so to speak, but they were there and they were part of the system, and so they studied them. And so what they they're wondering, what are the trout eating? Where are they spawning? And what they determined was that the rainbow trout were treating Spirit Lake effectively like an ocean. And so they would spawn somewhere in the tributaries sort of around it. And then they would come and move into the lake and spend a few years there. And then they would go back to the small streams surrounding to breed. And then, but they're also finding something else. And so as the trout numbers increased, as their abundance increased, the individual trout started to shrink, and they're shrinking at a constant rate. They're shedding an inch or two and ounces of mass every year. So that even though there was the same overall biomass of trout in Spirit Lake, it was the same amount of fish, but each fish was smaller. And so, as a consequence of that, there was this interest on the part of the state in opening a fishery, because what would happen is state biologists would go up to go fish and to survey, and they would bring some people along with them. This is an image of a volunteer, and the volunteers would catch these amazing fish, and there was a real pressure to open a fishery. But the federal managers, the Forest Service, which oversees the National Monument, has said no, and mostly for safety reasons and also access reasons, in part because of all the logs on Spirit Lake. If anybody were to take a boat out there and get so involved with catching a fish that you suddenly don't realize that you're surrounded by logs, and then your boat gets crushed and you die. Also, there's only one trail to Spirit Lake, and it's pretty steep. To provide access to the lake over the pumice plain would be really difficult. And so far, a fishery hasn't been allowed, but for me, this shows in a way the pressures of that, the arrival of the trout under mysterious circumstances, the really wacky dynamics of them. I've seen, only one place in the world, and then the pressures to allow, sort of more of a recreational relationship with them shows why the trout for me has become sort of this new kind of interesting colonizer, because where the prairie lupin was sort of explicitly ecological, the trout here are much more complicated, introduced pre-eruption, then cast out by the mountain, then brought back, most likely by people. And so, their presence leads to this debate of like, what is the monument for? What is natural and unnatural? How should people relate to this place? And so now I want to move to talk a little bit about the survivor, the elk. And so this is an image of a sort of bachelor herd of elk on the pumice plain. And animals like elk, this sort of large above ground fauna, did not fare terribly well in the eruption. State biologists estimated that about 1,500 elk were killed, along with 5,000 deer, perhaps 200 black bears, and some unknown number of cougars and bobcats and other things that were too large to hide in underground burrows. And so one of the things that was interesting about the elk was that the scientific approach to them would be different for animals like elk, other large mammals, than they were for small mammals, because there would be no need to search for survivors because everything was dead. But you could learn from the dead because their bodies could be found. And so this shows an elk skeleton that has been dug out of the ash a few miles from the eruption. And so the elks kind of acted as, this was sort of the Pompeii elk, they called them, after the city in Italy that was buried when Vesuvius erupted. And so finding these skeletons, two biologists initiated a study on elk calving grounds. So one of the things about elk is they form these large herds, but then with a male and a harem of females. But then with the pregnant females, as it gets closer in time for them to give birth, they separate themselves. And so where were they going? And nobody knew. And this was a sort of management interest. And at the time, this was in the sort of pre-cheap GPS days, the only way to find out where an elk was going was to put a radio collar on it and then stand on some exposed point holding a radio antenna aloft and listening for the beep, beep, beep. So that was one option. Or you could wait for a volcano to erupt and it would kill all the elk where they lay, and then you could go find the bodies. And that's what the biologists did. And so what they did was they mapped where the skeletons were, and they noted which skeletons were females. And some of the skeletons they found were actually two skeletons. There'd be a female and then a fetus, or a female and then nearby would be a calf. And so what this picture shows is boxes of elk skeletons at the Burke Museum of Natural History at the University of Washington in Seattle. And so these were skeletons that two biologists collected as they were doing this sort of post-mortem survey. And what they learned the types of meadows that elk use to give birth. And so this sort of helped them, give them a little bit of insight into elk habitat use that they would not have gotten otherwise. But the interesting thing about elk is that not all of them died. The Mount St. Helens elk herd is made up of about 10,000 animals, give or take. And if 1,500 of them died, that left a fair number that were still living. And so this image shows elk at the edge of the blast area in 1983. And so many elk survived just outside the blast area, and in some cases just outside the blast area. A biologist I talked to told me stories about going into survey elk in the early 80s, and she would look and see these elk watching her from a ridge, and their heads would be sort of oddly shaped. And she would look at them through binoculars and realize that what had happened was they were missing their ears because their ears had been burned off by the blast. They'd been close enough to be injured, but not so close as to die. But the thing about elk is that, so they were some of the first animals to return to the blast area because they're large and they're highly mobile. And so they would, from just outside, they'd come in a few hundred yards, and then they would usually leave. And so these first forays were pretty quick and brief, but they were venturing further and further in as the years passed. And what they were drawn by the fireweed, plants like fireweed that were sprouting all over the place. And so the elk biologists refer to things like fireweed as elk ice cream. They're really tasty and rich, and elk really like them a lot. And then in the winter, elk could forage on grass seeds that had been planted in the blast area along the debris avalanche for purposes of erosion control. And so elk rebounded at Mount St. Helens pretty quickly. From 1981, where they were only about 200 elk were counted just using the blast area, popping in, popping out. By 1985, there were 600 elk. And so this shows a picture. This image is of a mixed herd of elk in the debris avalanche deposits. And so there are lots of elk just sort of moving around. And the elk, the consequences for plants from elk were, at first, they were pretty good. Elk as agents of succession were beneficial. So as they moved into the gray wastes, they would poop, and each elk dropping, it was like a little prill of fertilizer, and then they would transport seeds. And so this picture shows a bunch of prairie lupins growing amidst a pile of elk poop. And then even also just in their active transit was good for plants because they had very sharp hooves, and so as they walked, they would break up the ash, which was really hard for plants to grow in, and so they'd create this more sort of friendlier sort of substrate for plants to grow in. And they ranged far and wide, and so they're on their pelt, they would carry seeds, and they would move them into the blast area, and it was all going very well. There were plants for them to eat, and there was, room for them to run, and so their population was growing. But their success came at a cost. As their numbers increased, they began to run out of food, and then they would starve in the winter. And so surveys that the Washington Department of Fish and Wildlife started in 1989, they would document that up to or over 150 elk might starve in the winter. And this was something that people in the communities that were around Mount St. Helens didn't really like to see. The elk would starve pretty horribly. They might see them kind of flopping around. The herd was subject to diseases like hoof rot disease. And so it was unpleasant. And so they didn't, they didn't really like to see nature take its course in quite this way. And so what happened is they started with these supplemental feeding programs in the winter where they would, state biologists would haul up hay from Oregon and dump it in these feedlots, and then elk would come and eat. And they continue these supplements continue to this day. And in 2019, the Rocky Mountain Elk Foundation gave about $310,000 in grants for habitat enhancement. And so the elk herd around Mount St. Helens has since stabilized. And as it has stabilized, their sort of successional influence as the years have gone by has changed from being largely positive to more mixed. And this is because as plant succession has sort of continued and the community has changed, the elk's effects have changed with it. And so this shows a young tree in the debris avalanche deposits. It's a young fir, and you can see that it's heavily browsed on the bottom. All the new growth has been eaten off. And so as trees are starting to return to the blast area, in the places where they haven't been for 30 or 35 years, the elk are really doing quite a number on them, eating all the new growth. They also stomp on plants as they walk. Before it was a good thing to have them walking because they would break up the ash, but now they're stepping on plants and tearing them apart. And so the question has become, is this is succession that's interrupted? As one biologist said, a herd of elk passing through a patch of land can set succession back 10 years. And so as a consequence, people have kind of stepped in in an effort to sort of control the impact of the elk on the blast area. And this isn't the first time that this has happened. So in 1982, as the elk numbers were increasing, the state instituted a hunt. And somewhat ironically, it was this hunt that drove the elk into the heart of the monument for the first time, because there were people hunting them on the fringe and the sort of debris avalanche deposits over at the edge. And so the elk moved into the monument where hunting wasn't allowed, and they discovered that it was a refuge, effectively a refuge. And so they stayed. And so in 2005, monument ecologists advocated for a limited hunt to drive elk out of the heart of the monument back into the sort of the wider landscape and to sort of lessen their impact. It didn't quite work out that way. As the monument ecologists hoped, what happened is the state, instead of a one-time hunt in the heart of the blast area, the state now has a hunt that has continued now for 15 years, all in other areas. So the elk continue to be, kind of pushed into the blast area, and they show no signs of leaving. And so in a way, this is, for me, what makes elk kind of a neat, new, sort of more modern mascot for the survivors, because it's a real test on the phrase ecological succession substantially unimpeded. And because the question becomes, unimpeded by whom? Elk are a natural part of the landscape. They have been for millennia. They came back to the mountain on their own, completely unaided. But they show also how Mount St. Helens will always be this sort of beautiful, complex space, very complicated, a place that is always that doesn't ever really give you an easy answer. And so I want to close with this time lapse of NASA showing the mountain recovering from 1979 until 2016. And so I hope I've showed you a little bit about what is new at Mount St. Helens, what Mount St. Helens shows us about how life responds to disturbance. And some of the things are that life will come back. It's very resilient, but even in the face of an unfathomable disaster, things will survive, things can return, but it may not come back as you expect it to, or even as you want it to. And I think that's one of the things that's most interesting, is that Mount St. Helens has been, thwarting expectation for decades. And so the only thing that makes sense is that it will continue to thwart expectation, and that it will always be sort of full of surprises. And I don't know, I think that is pretty neat as you watch the green kind of retake this land that they thought it would never come back to for quite a while. And so I want to thank you. Thanks for listening. I'm happy now to take questions, or if you have any, stories. Everybody's got a story about Mount St. Helens. So yeah, thank you. The book is After the Blast: The Ecological Recovery of Mount St. Helens. It's available from the UW Press right now. There's a massive sale because everybody's having massive sales. And so, yeah, I'm happy to take questions. Thanks very much.
Eric, thank you so much for coming and joining us tonight.
Well, thank you very much for having me. Let me set this up. Okay.
All right. So I just asked in the chat, if anyone has any questions, feel free to throw them in that comment section and we can ask them live to Eric here with us. But a question that came up for me was, I've been working alongside scientists on the Pumice Plain for a couple of years, and the theory about how fish return to Spirit Lake has changed over time.
Yes.
And the most recent theory that I've heard is that there is potentially a spring tributary, two tributaries that potentially merge at a certain time of year from the lower Lewis, or from the lower Toutle, I'm sorry. And so there's a theory that fish potentially had naturally migrated from that tributary into Spirit Lake. Did that come up in any of your in your studies for your book?
I mean, yeah, I heard that. I think I don't know if that's been investigated. I don't think it has yet. I think there are I think the reason that I didn't put it in was because it hasn't been, right now pretty hypothetical. So yeah, but I did hear that was a possibility that they could have made their way back through. I think the other thing I was thinking though was that given the sort of likelihood of the way fish tend to make it into mountain lakes in the Pacific Northwest, a human mediated introduction seemed more probable, but I would love, it would be fascinating to see if that ended up being the case, that they, at some point made their way back up through this tributary that was, temporarily reconnected. And I mean, especially for the conservation implications that would come from that, because of, that would mean that they were more closely connected to North Fork, Toutle, steelhead runs, which are endangered and protected, and what that would mean for managing Spirit Lake and sort of the issues therein.
Great. So Kathleen Mintz asked in the chat, did the hay from the elk that folks were using to sort of lure them in, did they help bring in new plants or introduce other species that you know about?
Oh gosh, no. I don't know about that for sure. I think one of the things is they weren't putting the hay in the monument itself. It was in the sort of surrounding area, like near I want to say it was near Randall or and outside of the monument definitely. And so, because I mean the Mount St. Helens herd covers a huge area, and so some of it's on monument land, others on DNR land, and stuff like that. And so I don't think there is as much of a concern about introduced species making it to the monuments from the hay. One of the issues that did come up though was whether or not the elk were actually able to digest the hay, whether it helped them or whether it just sat in their bellies like a space filler. So yeah, the management of the elk and the winter kill is convoluted.
Sure. And Miriam Phillips from Maryland asked, besides the elk herds, what are some other, I'm going to say charismatic megafauna that we might find, or even small animals that we might find in the...
Sure. So there's a lot. I mean, there are deer, there are cougars, bobcats, black bears. The main biologist is, some of you may know, I saw somebody ask this in the comments, is Charlie Crisafulli, and he has a pretty robust remote camera sort of network that he puts out every year, and he's found all sorts of stuff. So, I mean, most of the things that were at the mountain before it erupted have come back in some capacity. And yeah, there's a lot that you can see there. I think there was a cougar a couple of years ago that was causing some problems for hikers. And I mean, there are all sorts of birds, there are river otters. There's things that you wouldn't necessarily expect to see up there. Like at Spirit, I'm a big birder, and so at night you'd hear like Caspian terns flying overhead. And I grew up on the Columbia River and was like, what the heck? That was always kind of a strange moment.
Wow, amazing.
Yeah, there's a lot to see, even though outwardly it looks pretty spare.
And some rod hookers asking about reptile return to Mount St. Helens. What's the story about reptiles and amphibians?
So the story about reptiles and amphibians is pretty, so amphibians, some of them actually did fairly well. The amphibian story is the one that I know better. The main amphibian that I sort of came across was the western toad. The story of which is pretty fascinating, because so western toads are endangered or threatened. They're not common, and in the pre-eruption sort of community, they were at Mount St. Helens, but they weren't there in any great number. But in the aftermath of the blast, so western toads like open habitat, and an eruption, it cleared the forest out, and so it made a lot of habitat that was very well suited to western toads. And also, since a lot of their predators had been extirpated temporarily, and so their populations just exploded. And I don't know if you've seen their sort of the masses of toadlets that emerge from the lakes, like Meta Lake, especially in July. The ground is it's just crawling with little tiny toadlets that are like an inch long. They're the most delicate things you've ever seen, and they're just all over the place. And so the western toad did fantastically for a while, but as in sort of a nice sort of example of the sort of continuing dynamism of the landscape, as the trees have returned, it's become less open habitat, and so the toad numbers are sort of starting to decline, and so it's no longer quite the toad bonanza that it used to be. Another fun amphibian is the tree frog, or the Pacific chorus frog, which is it's like adults are maybe a couple of inches long. They're sort of pretty green. You see them sort of clinging to things from time to time, and you certainly hear them all over the place. And in the hummocks on the western side of the mountain, there are a number of ponds, these sort of ponds of varying duration, seasonal ponds that some dry out in the summer, some dry out in the fall, and so on. So watching the toad or the tree frogs there have some pretty interesting dynamics of where they populate, where they do well, where they don't. And that's one of the things that Charlie Crisafulli is really looking at very closely right now, is like how their dynamics sort of jibe with the seasonality of the ponds.
Yeah. What is your personal interest in Mount St. Helens? What inspired you to write this book?
Gosh, so I'm from Oregon, from Astoria, which is I don't know if people are familiar with it. It's a small town on the coast, pretty much at the Oregon-Washington border, at the mouth of the Columbia. And so, I guess in the way of many Northwesterners, I was 2 when the mountain erupted, or the big eruption. And so I don't, obviously don't have much of a memory of it, but it's always sort of had a place in your mind. And then, in a true sort of, I'll be honest. I could say I was inspired and been wanting to write about it forever and ever and ever, but it was really a bit more mercenary. An editor at the University of Washington Press was like, hey, you're an ecologist. Mount St. Helens is famous in ecological circles, what do you think? And I thought, okay, sure. In part because it was a very familiar landscape. Like, I've been there, I've been hiking there for a long time, and sort of thought I knew it. But then once you start to look into it and dig a little bit deeper, you realize just how little there And so that was really the experience for me, was just, reading so much and finding so much and learning just all the different ways that people have looked at Mount St. Helens for the past 40 years was really, it was really, really cool. And so I will say, at times I was looking, oh my, I bit off way more than I could chew. And I was, I was like, am I ever going to finish this? I missed my original deadline by a year. My editor was like, haha, that's fine, through gritted teeth. And, but really in the end, it was just, I don't know, this kind of mix of curiosity and familiarity and stupidity that makes all the best projects.
Because your PhD work is on penguins, Argentinian penguins. So this is a pretty big departure from some of your other book topics.
Yeah, well, the thing that was really tough for me was all the plants. I'm not a botanist, and I was an indifferent student of plant ecology, I will admit, to my great shame. And botanists are very, very, very careful people. I mean, not to say that animal ecologists aren't, but like, there's a real, the taxonomy in botany is very robust, much more, and much, I don't know, at least in my dabblings, like a lot of the findings sort of hinge on certain sort of taxonomical expertise, and that I am, decades, hundreds, centuries, millennia away from even approaching. And so that was a real, there's a lot of, like, the mountain really humbles you in ways you don't expect. And that was one of them for me, was having to sort of bow and scrape before all these plant ecologists and be like, please correct all my stupid errors, don't spare my feelings. And they didn't. So there you go.
So you must have learned a great deal through this process.
Oh, gosh. I mean, the thing is, like, it's one of the things that's sort of frustrating about writing a book is that once you finish, there's no way it's the final word, and projects continue. Things that I wrote about have advanced, which is really frustrating for me. Like, because I think eventually, like, there will be a paperback at some point, and then I have all these plans for things that I'm going to update. So it was interesting that way.
Mimi Delker is asking in the chat, were you able to speak to any of the volcanologists or ecologists or other scientists that were around during the blast of the 1980?
Yes, I was very, very lucky. So the project for me started in 2015 at an event called The Pulse. And these pulses, right now they're about every 5 years, but in the beginning I think they were pretty much every year. And a pulse, a science pulse they called it, is when all the scientists, all the ecologists who've been working at Mount St. Helens sort of gather together, and they, for about a week in the summer, and they talk and share stories and toss around ideas for new studies and things like that. And so I went to the Pulse in 2015 to just sort of meet everybody. And it's one of those things when you're writing about a place that has been studied for 40 years by pretty much many of the same people, is that now many of them are starting to get old. And there's this sense of, I talk about this a bit in the book, is that, so one of the main sort of themes of the research at Mount St. Helens, obviously, is ecological succession, or like how plants communities change through time. But one of the things that was really interesting was seeing how succession plays out professionally as well, a different kind of ecological succession, as researchers who've been there and, have all this knowledge and this, that these people who constitute basically Mount St. Helens' institutional memory near retirement age. And in some cases, some of them have passed away. And so there's that sense of passing, there was a real sense of passing of the torch of, folks who were teaching younger ecologists. And that was also one of the really fascinating things, was seeing how these older approaches, more, 1980s ecology is very, very different from 2020s ecology or 2010s ecology. Just from like statistical methods and other methods and things like that. And so watching the ways that people ask questions then sort of transition to the ways that people ask questions now was one of the most interesting parts. Because in part, like, long-term ecological research, it's really like worth its weight in gold to have these massive data sets to be able to watch change through time is pretty uncommon. And Mount St. Helens is a really excellent example of that.
Let me see here. Somebody was asking for a little bit more information on hoof disease that's affecting the elk herds. And you
So I
mentioned a
don't,
little bit, but
that's I'd say the place to go would be the Washington Department of Fish and Wildlife site. Like they have biologists who are working on it and tracking it, and so I am not current on it, so I won't, idly speculate.
so I'm wondering, maybe just as a closing question, what was one of the most interesting things or most surprising things that you discovered during this process for you?
Gosh. So I would say I would actually go back to the amphibians and the little Pacific tree frog. And Charlie Crisafulli had told me this story about finding a tree frog in the crater of Mount St. Helens. And somehow this little frog had hopped. I think the nearest source population was something like 5 or 6 miles away, and so somehow over the course of its motile life, this frog had hopped up a drainage all the way into the crater where it was living happily in some sort of melt pool. And that just seemed to really exemplify so much of the project for me. The community of these animals doing strange things that you wouldn't expect and showing these surprising qualities and traits, and being pretty blasé about it at the same time. This frog doesn't know it's some sort of enterprising hero. It's just a frog hopping up a drainage. And so that, I don't know, that learning those sorts of details was a lot of fun.
Eric, thank you so much for joining us, and for all of you out there still with us, we really appreciate you tuning in today. And if you enjoyed this program, want to see more in the future, log on to mshinstitute.org/give to make a donation and ensure that we can offer programs like this and have speakers like Eric join us in the future. Next Monday, we have at 6 p.m. Pacific time, same thing. We're looking at the culture of Mount St. Helens with writers Christine Colasurdo, Rick McClure, and the Cowlitz elder and spiritual leader Tana Engdahl. So come and join us for What Does Mount St. Helens Mean to You? And in the meantime, visit our website, follow us on social media. We're offering several stay-at-home activities through our new campaign, MSH Inside. So we hope to explore the volcano with you soon. Thank you so much. Have a great night.
Good night. Thank you.
Thanks, Eric.
Thank you so much. That was great.
Thank you. Thanks for having me. I don't know. I couldn't listen to it, so I just muted it and sat off to the side with a kind of checking every so often. But did it go okay, or?
Yeah, it went fine. I mean,
Okay,
I was
great.
watching it and I was interested. Super good stuff. Like it's cool. So
Cool. Okay, great.
thank you. Yeah. I think everybody enjoyed it at home. So yeah.
Who knows, but yeah.
Yeah, Jared, did you happen to see what the numbers that I saw were around like 80 people logging on?
Yeah, we didn't, the numbers weren't as high, but the cool thing about this being online is that it lives online forever, essentially, or at least until the internet goes away. So yeah, and this is content that people will keep watching. I got an email last week from a guy in Seattle who was like, "Thank you so much for putting this online. I'm so excited." Because he doesn't want to drive to Vancouver. I don't blame him. I have driven back to Seattle many times. I know that drive. So yeah, no, I think it's great. I think it's perfect.
Great. All right. Well, thank you so much.
Thank you.
Thank
That
you.
was awesome.
Yeah. Oh, thanks. And yeah, I look forward to seeing. Actually, I'll probably be in the audience next Monday because it'll be neat to hear that. I think one of the things that's neat is that I got kind of a blinkered view of Mount St. Helens with so much ecology, and so it's good to hear that other stuff too and be reminded that it exists. So anyway, yeah, looking forward to it.
Cool.
Yeah, I just looked on our Facebook page, and as of right now, the one from last week has 3.2 thousand views.
Wow.
So You
So,
just never know.
Yeah,
It
no, that's
was-
great. I'm you know, I'm happy if there's one or two people. I don't really get too worked up. So yeah, thanks for providing a venue.
yeah, happy to do it. Would love to have you come back and speak in person when the world is open to that
Great,
sort
yeah.
of thing.
Well, the paperback comes out next year, so that would be at about this time. So
All right, on.
Great.
I can come do that.
Perfect.
Hopefully, we'll be open and functioning. But
Fingers crossed. But yeah.
Yeah.
Cool.
Jared, thanks for running the back end. Sorry
Yeah.
about the.
Yeah, I'm sorry I put you in the Inception view.
that was cool. That was
Oh.
Oh, don't worry about it. No one cares.
no one cares. It's just, I mean, it's value added.
There you go.
People
Yeah,
thought
it
it
was
was
a fun
funny.
thing. It was
Yeah.
a fun thing. So
Cool.
All right,
Cool.
so you guys go get some dinner.
I was gonna say I'm gonna go eat. So
I'm hungry.
yeah.
yeah, I got
Oh.
some crock pot dining waiting for me. So
Delish.
All right.
All right. Well, thanks
You guys
again.
rock.
Yeah,
Yes.
and
thank you.
hopefully I don't know if the pulse ends up happening and you're there. Or hopefully I'll see you.
Yeah, for sure. Yeah,
All right.
definitely.
Cool.
We'll talk soon.
Okay.
Bye.
Take care. Good night.